Hello, bachcha log. I hope you people are doing really great. Your preparation for GATE is going in a good, correct direction, beta. Already, I have provided so many sessions in this one short series. We have already covered simple mechanism. We have already covered velocity analysis, acceleration analysis, gears ke bare mein we have already discussed. And today, in the same sense, we are also going to discuss two, again, very important chapters of theory of machine, which is flywheel and balancing. These two individually, these two are very small topics, small chapters. There are going to be very few concepts which you have to learn, but believe me, beta, if you have clearly understood these concepts, so examinations may, if any question is framed here with the help of these few concepts, very, in a comfortable way, if you have understood these concepts, whatever questions they are going to ask, you can easily solve them, beta. Chaliye. So let's start. First, let's have discussion about flywheel. In this chapter, I will be covering majorly flywheel, balancing of rotating masses and balancing of reciprocating masses, beta. And then we will see, in between, we will also see some questions which have been already asked in GATE, so that you can get a glimpse that what kind of questions you can expect, which kind of preparation do you need actually. Acha, listen carefully. Many of times you people have seen in your generators outside your home, you have generator mein you have seen a big size wheel. What is that? That is the flywheel. In your automobiles, you may also have seen a disc kind of structure, very small size ka disc is used. What is that? That is flywheel. Sometimes in industries, railways mein, earlier days mein, this big size of flywheel used to be there. Industries mein, punching machine mein, you might have seen huge wheel running, running with the engine. What is that? That is flywheel. So flywheel, doesn't matter whether you have studied or not, you have seen that. Everybody have seen. But yeah, what is flywheel? How does it look? Now we are going to discuss, or we can say at the end of this chapter, you will be able to identify where we need flywheel, in which kind of situations flywheel is going to be used. Not in every place. Randomly, we are not going to connect flywheel in every place. Whenever we are going to use engine, whenever we are going to use motor, many people think that, sir, whenever we are going to use engine, flywheel will be required. Abhe nahi, aisa nahi hota hai. Whether it is engine or it is motor, at the end of this chapter, you will be able to give me the answer of this question, that how can we say whether in this situation flywheel is needed or not. Acha, before starting this chapter, let me write one sentence, and at the end we will come back again here. Flywheel, whenever, doesn't matter whether we are using engine or we are using motor, doesn't matter, irrespective of that, whenever available torque, let me write, whenever available torque and resisting torque, or which can also be said as required torque, whenever available torque and required torque, resisting torque are different, flywheel is needed. Look here very carefully, beta. This available torque, what is the meaning of this available torque? Available torque means whatever your motor is providing, whatever your engine is providing, whatever input torque you are going to give. So available torque ki requirement, available torque, whatever available torque is there with you, and whatever is the torque, resisting torque there, whatever is the required torque is there. If there is differences between these two things, this is supply, this is demand. Whenever demand and supplies are different, we are going to use flywheel in that situation. This available torque, maybe this is available because of motor, because of engine. Engine generally it is going to produce fluctuating torque. We know this. I will show you why it is. But engines are going to provide you fluctuating torque. Motor, on the other hand, it is going to provide you constant torque. Doesn't matter you are going to use motor or engine. Whatever is the available torque and whatever is the resisting torque, if these two things are different, flywheel will be needed better. Acha, to explain my whatever I have said, to explain this thing, I will take example of a beautiful engine which is a steam engine. Double acting single cylinder steam engine का example ले रहा हूं. And you people, many of you are already aware with that. How does it work? A steam engine earlier days में railways में it was being used. And just avoid all this mechanism. Look at only this part where piston is there. Where you are having your piston beta. In this engine, you have this piston is going to have motion like this, reciprocating motion. And when it is having reciprocating motion, so when this piston is moving this side, from back side I have released compressed steam, and this compressed steam is going to push it in the forward direction. And when this piston is at the extreme position, from opposite side I will release compressed steam. Piston will come back. When my piston is going this side, extreme position, steam is there which is doing some work. When it is coming back from that side, I have released steam, and again while returning my piston is also getting some work from the opposite side of steam. बात समझ में आ रही है? So piston has moved from this side, inner dead center से outer dead center, and from outer dead center से inner dead center. This is one complete cycle, and in this duration your crank has rotated by one complete circle. 2 pi rotations it has done. For this double acting, from both sides I have released steam. That's why I am saying this word, double acting steam engine. Single cylinder double acting steam engine. Let me show you the graph. If I draw graph beta, graph means if I draw for one complete cycle, how torque is going to vary. If I draw that, it looks something like this. Sir, this is my theta. I am drawing my torque which is available with the engine. Here I will be drawing my torque. Please be this side. Bete, this is my crank. This is my connecting rod. And here this is my piston. This is fixed link. When my piston is moving from inner dead center to outer dead center, when it is moving this side, I have released steam from this side. It will give me some work. Piston has moved from this portion to this portion. And again, while returning, I have released steam from this side, and piston has traveled this distance. But from inner dead center to outer dead center to come back to this inner dead center wala position. And during this situation, when piston has moved this distance, my crank has already traveled 2 pi rotations beta. One complete circle it has done. Okay, and during this one complete rotation, one cycle is done. In the next moment pe, same thing is going to repeat. Next moment, same thing is going to repeat. So I will draw a diagram for one cycle, so that if I want to know what is the complete picture here, I must draw how torque available at this crank is going to vary. And that torque looks something like, sir, 0 से 2 pi. Why I am drawing 0 से 2 pi तक का diagram? Because I want to see the complete picture during one cycle. What is happening here inside in one complete cycle? If I can do analysis here, rest of the cycles में same thing is going to repeat. Acha, this is 0 degree. Somewhere here you are going to have 2 pi. Somewhere here in between you are going to have pi rotation. And if I draw torque ka diagram, so torque is going to vary 0 से something like this. This is how torque is going to vary beta. I'm not going into much detail why this kind of shape you are going to get. Clear hai na? This is how your torque is going to vary beta for double acting single cylinder steam engine. Now listen carefully. But my engine is producing a torque which is sometimes, when I see sometimes this torque is 0. Engine is producing this much torque. This is the available torque. Engine sometimes it is producing 0 torque. Sometimes it is producing some high torque, even higher torque, maximum torque. And then again torque is going to reduce at this, pi degree. Again torque is 0. Again it is varying to this maximum value. Again it is 0. So this is how my available torque is going to fluctuate. This yellow color say whatever I have drawn, this is my available torque beta. Let me write. Yellow color say I have drawn, this is my available torque. You can call it as available torque or engine torque. Available torque beta. Okay. Acha. How much energy your engine has produced? Sir, during this from here to here, this entire motion, my engine has done some work, and that work can be explained as whatever diagram is there, whatever is the area of this diagram, area under force versus displacement, or here rotation is there na. So area under torque versus theta diagram, you are going to get your entire energy which has been produced, total work done by the engine. This area, this entire area, bete, this entire area, this area, plus, sir, this entire area. Whatever is this thing, this entire area, this thing, this total area is showing how much work has been done in one complete cycle. Engine has done some work now. So this area under the curve is representing, let me write, area under the curve is going to represent, let me write somewhere here, area under T theta diagram, T theta curve, it shows work done in one cycle. How much work has been done in one cycle? Clear, na? If somebody is going to ask how you are going to calculate, whatever is the torque equation, sometimes they will give you the torque equation, how torque is going to vary. That torque equation T d theta, integrate kar dijiye from 0 to this, whatever is the time period. Whatever is the time period. In this case, 2 pi was the time period. For completing one cycle, how much is the time required? How much is the angle turned? So that is something which you are calling as the time period. So torque ka whatever equation, torque ka equation they are going to give. For example, they will give ki bhaiya how this torque is going to vary. Sir, for any engine, torque is varying something like 10,000 plus 500 sine 2 theta. Something like this will be given, Newton meter. This is how they have given the torque. And torque ka this equation, integrate kar dijiye from 0 to time period. This will be work done in one cycle. Acha. Now, suppose, देखो, most of the times engines ko we are going to connect against certain load. Engine, it is not running for himself. It is running so that it can be connected against certain load. In villages, engines is running so that it can be connected against the centrifugal pump, so that water can be lifted from the well. In day-to-day life, generators are connected to the dynamo so that electricity can be produced, so that it can take care of your household's requirement. So whatever prime mover you are talking about, whether it is engine or motor, it is going to be connected to some load. Acha. Generally, that load is going to be constant. And how much that load can be? Beta. If you can easily calculate mean torque. What is the meaning of mean torque, bete? Arey, sir, this total amount of energy, actually it is being produced here. I can understand this amount of energy is being produced. But this amount of energy is not available at a constant rate. Sometimes torque is very high, sometimes torque is 0. Again, it is very high, sometimes it is 0. What if this entire area, if this entire energy was available at constant rate? Constant rate का मतलब होता है with a constant torque. Sir, draw करिए hypothetical torque. You are not going to get this. Just a mathematical concept कि भाई, if I calculate this total amount of energy from 0 to 2 pi in one complete cycle, if it was available at constant rate, so that torque will be represented something like this. This is going to be that torque. Acha, दिस ग्रीन कलर की लाइन वॉट एवर आई हैव शोन, दिस इज योर मीन टॉर्क बेटे. ग्रीन कलर की लाइन से आई हैव शोन दिस इज मीन टॉर्क. And how do we calculate mean torque? Technically, the definition says mean torque can be calculated as by mean torque multiply area under the mean torque will be exactly same as work done in one cycle. Same amount of energy. You are assuming that if this amount of energy was available at constant rate, so how much that torque would be? Mean torque area under the curve कितना हो जाएगा बेटा? Mean torque this entire energy. ये entire energy, can I write this energy is exactly same as total energy of this earlier whatever you have calculated here. Can I write beta? That's what I'm writing. Mean torque multiplied by whatever is the time period, it will be equal to work done in one cycle. Same whatever you have calculated here. So whatever you have calculated divided by time period, if you are going to do, you will get how much is the mean torque beta. Getting a point? Work done in one cycle, just calculate कर लीजिए. How? This is the formula I have written, divided by time period, and you will get your mean torque. Examination में they will ask a question. Examination में they will ask questions sometimes where you have to simply calculate how much is the mean torque. Now let me give you a hint. बेटे examination में if you will do this all this calculation, whatever is the torque equation they have given, integrate kariye from 0 to time period divided by time period, you will get this value. Always you are going to get this value. Acha, clearly it is visible also. Sir, torque ka equation you have written some 10,000 plus something sin theta plus something cos theta, something like this. Examinations where they are going to give. This term is representing the mean torque, and these terms which are having sin, cos with them, they are just representing fluctuation. Means your actual torque of the engine is going to vary about this term 10,000 k about. It is going to, it is sometimes it will be increased from this value, sometimes it will decrease from this value, but again fluctuation will be about this only. This is your mean torque, and mean torque about fluctuation is going to be there. Getting a point? That's what this is. What this is the feeling of mean torque. Mean का मतलब समझते हैं? Mean is average. Average means sometimes my torque is higher, sometimes my torque is lower. Obviously बात है. Sometimes this is the average, this is the mean. Sometimes actual values will be higher than this, sometimes it will be lower than this. Higher, lower, higher, lower. Fluctuations only about this average, fluctuations are going to be there. So always examinations when they have given question, and directly you don't need any calculation, directly tell that this is going to be your mean torque beta. No need to do any calculation. How we have got this thing? Arey sir, you have calculated this work done in one cycle divided by then time period. Answer, it is going to be this. Either you can do mathematical calculation by your own, or just believe me better, this is always going to be your mean torque. So your time will be saved. Directly tell that this is whatever term which is independent of theta. This is constant term. About this 10,000, you are going to have fluctuations. Other sine and cos value terms, they are just representing fluctuations. Let me write. But this is the mean torque. All these terms, sine, theta, cos, theta, whatever terms you are having, this is representing only fluctuation. Only fluctuation. Now, if you know how much is the mean torque, this is my mean torque. Green color say I have drawn the mean torque beta. Now listen carefully. This engine I can connect against certain load, and that load most of the time it is constant. Not necessary, but most of the time that load is going to be constant. And that constant load, if you will ask me how much load you want to connect against this engine, so bhai, I want to fully utilize my engine. Whatever energy my engine is developing, I want a load which requires exactly same amount of energy. समझ रहे हो? If a lesser load is there, so bhai, engine is producing huge amount of work and you require only very less thing. Rest everything is going to be wasted. If you are going to connect higher load than mean torque, तो सर भैया इंजन विल नॉट बी एबल टू ड्राइव दिस, ऑब्वियस सी बात है. सो फुल यूटिलाइजेशन के लिए आई विल चूज a load which is same magnitude wise, exactly same as mean torque. Again beta, I am saying again, it is not compulsory that resisting torque have to be constant. I am not saying this, I am just saying that most of the time engines are connected against a constant load, and that constant load is going to be same as mean torque. Why? Less than mean torque I will not use, because sir my engine ka energy, rest of the energy is going to be wasted. For complete utilization, I will, keep my resisting torque same as mean torque. Higher than mean torque, I cannot use, because it will be beyond the capacity of my engine. So, suppose, same as mean torque, magnitude wise, exactly same amount of torque you have produced, you have connected against this engine, and this line, which is just overlapping over this mean torque, I have drawn. What is this? This color, red kind of color, purple color, it is representing how much is the resisting torque. Some people call it as resisting torque, some people call it as load torque, your choice. एक ही बात है. Or you can also say required torque. This much amount of the torque which is required. If now this is the complete picture. There is an engine which is producing this much amount of the torque. Sir, you have an engine which is producing torque like this in one cycle. You have certain loads which requires torque at constant rate during this entire cycle. So one cycle mein always you have to draw the picture, complete picture in one cycle. And in this one cycle, once you have drawn the diagram, T theta diagram, how available torque is fluctuating, how required torque, resisting torque is going to vary. And if you can see any differences, क्या तुम्हें differences दिखाई पड़ रहे हैं? Yes sir, there are differences. My available torque sometimes it is 0, but requirement was something. Some torque was required, but my engine was producing nothing. Sometimes my engine was producing only this much amount of torque. Exactly at the same time, requirement was this. Requirement was high, but my engine is producing less. Sometimes few situations will be there that my engine is producing exactly same amount of torque which is required, but many of the times you may be having a situation when available torque is very high. So this is the torque produced by the engine, requirement is very less, only this is the requirement. So most of the time available torque will be higher than required, not of my use. Available torque will be sometimes less than the required. So this is a trouble wala situation. Few situations may be there when exactly same amount of torque is being produced by engine which is required by the load. Only at these 3-4 points. And can you see these kind of situations you are going to have only at few points, sir. Yahan par. These are the points, intersection points of these two graphs. Which graphs? Available torque and resisting torque ke intersection points. These are the situations when exactly whatever is the required, that is being produced. Only at these 4 points, flywheel is doing nothing. Rest everywhere, flywheel is going to play a major important role. And what is that role, beta? Bete, listen carefully. Whenever surplus amount of energy is there, what is the meaning of surplus amount of energy? Sir, torque is being produced is very high, requirement is very less. So this is the excess amount of energy which is being produced. It will be wasted. If you are not going to use this, it will be wasted. Rest of the time pay, sir, when requirement is high but available is very less, in this case, engine will be having trouble in operating against that load. So what? Let's do one thing. Let's connect a flywheel, and that flywheel is going to have an important role. That flywheel will absorb this amount of energy, surplus amount of energies. Acha. This is surplus amount of energy, flywheel will absorb. Ye surplus amount of energy, flywheel will absorb. And whenever flywheel feels that energy is needed, load requires energy, but my engine is not able to produce exactly same amount. तो भाई flywheel will give additional whatever energy flywheel has absorbed here, flywheel will deliver those energies whenever it feels that requirement is there. Sir, here requirement is there, flywheel will deliver. Here flywheel will deliver certain amount of energy. Getting my point? Here flywheel will deliver. Sir, here flywheel will deliver. Wherever you are going to have differences, flywheel will deliver certain amount of energy. Negative energy, negative energy, negative. Negative means flywheel will deliver here. यहाँ पर flywheel is going to have absorb. Flywheel is going to absorb the energy. अच्छा, keep this thing in mind because this is the mean torque. Same, you are having your resisting torque. तो बेटे mean के above whatever fluctuations are there, mean के below you are going to have same amount of fluctuations. Even a blind person can tell that these fluctuations, positive fluctuations, are same as this plus this. Whatever positive areas are there, negative areas will be exactly same magnitude ka. Getting my point? Getting my point? Area above the mean torque and area below the mean torque. Positive areas ka summation and negative areas ka summation will be exactly same. Let me write this point. Let me write this point somewhere here. Important point is there, beta. Summation of positive areas will be same as magnitude wise exactly same as summation of negative areas. Getting my point, beta? So whatever energy flywheel is going to absorb here, flywheel ने this much amount of energy absorb किया है, यहाँ पर absorb किया है, and flywheel here it will deliver some energy, flywheel will deliver some energy here, flywheel will deliver some energy here. At the end of the cycle, flywheel will have no surplus amount of energy. Whatever flywheel has absorbed during the cycle flywheel has given that. Getting my point? You people can think about flywheel in such a manner कि भैया flywheel is a गुल्लक. You know what is a गुल्लक? अब गुल्लक को इंग्लिश में क्या कहते हैं? I don't know that. गुल्लक is a piggy bank. Piggy bank. For childrens we give that piggy bank ना. Piggy bank में I will give children sometimes 10 rupees pocket money, 20 rupees pocket money, sometimes 50 rupees. Some uncle has visited my house and he has given 100 rupees to the child. So the child is going to store that money. And whenever he requires to purchase some toy which cost 500 rupees, so whatever he has, given to that piggy bank, once it is sufficient and this child requires certain amount of money, so he will take that money from here, invest in that toy. Getting my point? Exactly same thing your flywheel is going to do. Flywheel is just a reservoir. It is going to absorb energy whenever surplus energy is available. Some relative has given some money, it will absorb. Someone has given energy, it will absorb. Whenever it needs, your requirement is high, but available energy is very, very less, it will deliver certain amount of energy. Getting my point? This is how your flywheel is going to work. Now, if everybody is comfortable till this point that how flywheel is going to work, we can talk in detail about some analysis. How many of you can imagine when flywheel will absorb this amount of energy? When I say flywheel will absorb energy, flywheel will release energy. Flywheel is a rotating disc and rotating part can absorb energy, release energy. It can do transactions of energy in terms of kinetic energy only. So when your flywheel is going to absorb energy, it's this much amount of energy it has absorbed. So by flywheel ka energy will be increased. Flywheel ka energy will be something maximum. Absorb kiya hai na? Something maximum. Its angular speed is going to increase. Omega will be something maximum. Let me write this thing also. यहीं पर लिख देते हैं बेटा. Flywheel will do transactions of energy. Transactions of energy in the form of kinetic energy, rotational kinetic energy. And what is that rotational kinetic energy, beta? Flywheel, maybe in the form of disc or ring, whatever, it is going to have some inertia I. So energy is going to be half I omega square beta. Omega is angular velocity of the flywheel, I is inertia. So half I omega square is the rotational kinetic energy. Flywheel has absorbed energy. That means energy will increase. Moment of inertia is not going to change. Omega will change. Omega has increased. Next moment flywheel has delivered this much amount of energy. So भाई यहाँ पर आते आते its energy will be reduced. At this point, its energy will be E minimum, or I can say omega minimum हो जाएगा. Again, at this point, it will absorb this amount of energy. Again, its energy will become maximum. Acha, already one maximum I have written. Maybe this energy is something different. So you are going to have, let me write, this is maximum 1, maximum 1. This is maximum 2. Some other maximum. After absorption of energy, its energy is going to increase. Its value will become something maximum. This maximum may be different. This is maximum 2, something different maximum. And then omega will be maximum again. Maximum 2 I have written. Again, it is going to deliver some energy here, and at this point, its energy is going to be something minimum, or omega something minimum. Again, there are two minimum, so I will call this as minimum 1, and this is as minimum 2. Getting my point? Getting my point? Acha. How effective your flywheel is going to act, to judge this, to gauge this, we have two parameters. One is which is called as coefficient of fluctuation of speed. Coefficient of fluctuation of speed, which is denoted by CS. And this is defined as, CS is defined as beta. Whatever is the maximum fluctuation in the speed, whatever is the maximum fluctuation से मेरा मतलब है during this cycle, flywheel का speed is going to be sometimes maximum 1, maximum 2, maximum 3. Sometimes it will reduce, minimum 1, minimum 2, minimum 3. So भैया whatever is the highest वाला maximum and lowest वाला minimum between these, क्योंकि flywheel का speed maximum will be this, minimum will be this. So fluctuation, maximum fluctuation during one cycle, flywheel का speed is varying between this maximum and this minimum. So this is something which is called as fluctuation, maximum fluctuation of speed. And that, let me write, maximum of all the maximum, omega maximum 1, omega maximum 2, and so on. Whatever maximums are there, all the maximums ka, whatever is the maximum, that is called as omega maximum. And omega minimum, least speed of the flywheel, is minimum of all the minimum. Sir, sometimes it was minimum 1, sometimes it was minimum 2. Sometimes it was minimum 2, and so on. All these minimum ka, whatever is the minimum, speed will be varying between these two extreme positions. Getting a point? The coefficient of fluctuation of speed is defined as, what is the fluctuation? Omega maximum minus omega minimum. This difference divided by mean speed. What is the mean speed, beta? Mean speed is maximum plus minimum divided by 2. Getting my point? Getting my point? Acha. Very, very careful. Either you can calculate fluctuation of speed, either you can calculate fluctuations in terms of speed, or you can also calculate fluctuations in terms of energy also. We have another term which is called as coefficient of fluctuation of energy. Coefficient of fluctuation of energy, CE. We denote this by CE. And how it is defined? Sir, CE, similarly, all the maximum energies. Sir, maximum 1, maximum 2, maximum 3. In one cycle, whatever maximums are there, largest of that that energy minus least of all the minimum. This difference will be known as maximum energy minus minimum energy divided by work done in one cycle. How much is the work done in one cycle? This is something which is known as coefficient of fluctuation of energy. Getting my point बेटा? Getting my point? ये बात समझ में आ रही सारे बच्चों को? अच्छा, now listen carefully. Listen carefully. देखो, ultimate aim of the flywheel is कि sir, if I connect my flywheel against certain load, so intra-cycle fluctuations should be less, minimum coefficient. I will say my flywheel is acting in a very good manner. Lesser is this coefficient, either this coefficient of fluctuation of speed or this coefficient of fluctuation of energy. Lesser the value of these coefficients, I will say my flywheel is super awesome. Technically, if somebody is asking me, sir, what is your dream? I will say, bhai, I want coefficient of fluctuation of speed 0. Matlab, just by adding flywheel, I want all the fluctuations are gone. But that's not possible. That's my dream. Best to tab hoga when this coefficient will become 0 or very, very close to 0. Getting a point? Lesser is the value, I will be happy. I will say my flywheel is better. Getting a point? ये बातें समझ में आ रही हैं? अच्छा, एग्जामिनेशन में this coefficient of fluctuation of speed, sometimes it will be given. Let me write coefficient of fluctuation of speed. Let me remove this entire thing. Examination में sometimes coefficient of fluctuation of speed they will give directly. They will tell you by coefficient of fluctuation of speed is 0.1. Either they will give like this, or sometimes it will be given in terms of percentage. Percentage में they can give 0.1 they can write, or same 0.1 को they can write as 10% fluctuation is there. 10% fluctuation is there. अब इस 10% fluctuation about the mean speed is there. अब इस 10% को they can either write 10% or sometimes they can also write as plus minus 5%. Getting a point? अरे भाई, if this is 100, तो speed का fluctuation is either you can call it as plus minus 5%. plus minus 5% का मतलब होता है कि भाई speed plus 5% ऊपर जा रही है, it is going up, and minus 5% it is coming down. Speed increase होते होते it may reach 105, and by reducing it may reach up to 95. Getting a point? 105 and 95. This is the meaning of plus minus 500. Plus 5 किया है, you will reach here. Minus 5 किया है, you will reach here. And fluctuation कितना है बेटा? From this value, maximum speed and minimum speed. This is the mean speed बेटा. This is something which is fluctuation. Either they will say that this is plus minus 5%, or sometimes they may say कि भाई 100% के आस, about this 100%, 10% fluctuation is there. 10% का मतलब होता है 10%. That's it. This fluctuation का value they have given 10%. Sir, this is 10%. अब ये 10% may be only one side, or maybe only this lower side, or maybe both side. Getting a point? This 10% is given as 10%. That's many of the students are going to commit mistake. They will put some extra mind here, and they will say that examiner has said, sir, 10% fluctuation is allowed. 10% ऊपर, 10% नीचे, total 20% हो गया ना. If they have to mention, if they want कि भाई both side में consider करो, they will clearly write 10% fluctuations both side of the mean speed. They will mention this word, or they will mention this plus minus thing here. Don't, if they have simply written 10% fluctuation is there, तो भैया 10% का मतलब होता है simply 10%. That's it. Don't be over smart here. Otherwise, you are going to get option A as your answer. Clear है ना? ये बात समझ में आ रही है? अच्छा. Now, one thing is clear to everybody कि sir, flywheel, as you mentioned that it is going to act as a piggy bank. During cycle, surplus energy it will store. Whenever it feels that energy is required, whatever it has stored, it will give from that. Again, surplus energy, it will store. Again, some energy deficiency is there, energy is less, it will, release some amount of energy. This is how your flywheel is going to act, beta. Getting open, this is how your flywheel is going to act. It will store energy in the form of kinetic energy. Positive areas ka summation will be exactly same as negative areas. Now, how do we design flywheel, which is called as fundamental equation of flywheel? Fundamental equation of flywheel. Fundamental equation of flywheel. How do we write this equation, beta? Are dekho, ultimately, if I take a flywheel which can handle maximum fluctuations. What is the meaning of maximum fluctuations, beta? Sir, maximum energy minus minimum energy. This difference is something which is called as maximum fluctuation. Delta E max का value, if you know, delta E max क्या होता है बेटा? Delta E max is equal to maximum energy minus minimum energy. These things, maximum energy you can write as half I omega maximum square minus half I omega minimum square. Don't worry, I'm not doing derivation here. Don't worry. I'm not doing derivation. I'm just telling you what equations can be used in the examination. Sir, either you can directly use this thing. Sometimes questions will be asked and you can use this as your formula. Maximum fluctuation of energy. Just identify. How do we calculate that? From the graph. You have to draw the graph. Torque theta diagram draw करिए. Available torque क्या है? How much is the available torque? How much is the resisting torque? Just find out the loops, positive loops, negative loops, fluctuations, which we call. है ना? E maximum energy 1, maximum energy 2, maximum energy 3, minimum energy 1, 2, 3. All the maximum ka largest, all the minimum ka least. This difference is delta E max. Once you know the delta E max, sometimes objective questions it will be very, very easy. They will directly give कि भाई सुनो, ये लो, this this is the delta E max ka value. They will give you delta E max and they will ask sometimes कि भैया tell me how much is the moment of inertia of the flywheel which is required here, so that maximum speed and minimum speed are this. या फिर a little simplify, if you'll do a little simplification, same equation can be written as delta E max is equal to I omega square CS. I क्या है? This is I is moment of inertia of the flywheel. Omega is mean speed. This omega is mean speed, and CS ka value is, CS is nothing but coefficient of fluctuation of speed. Sometimes you will use this equation, but both these equations are exactly same. A little bit rearrangement I have done. अरे यार, half I can be taken as common. अंदर बचेगा. What will be left inside? Maximum omega maximum square minus omega minimum square. A square minus B square. है ना? This omega maximum minus minimum squares को you have converted into mean speed and fluctuations of speed. Some rearrangement. That derivational part is not important for you. What is important for you is to understand this equation, and you must know how to use these equations better. ठीक है ना? Again, now coming back to the same question which I have asked in the starting of this session. If somebody is going to ask you, tell me when flywheel is going to be used, never say, sir, in engines we are going to use flywheel. Na. Engines में flywheel चाहिए होता है. This is not a compulsion, beta. Na, this is not a compulsion at all. Flywheel, never ever say that in case of engines we are going to use flywheel, or motors में flywheel नहीं चाहिए होता है. Never use these words. Let me show you a situation, sir. Let me show you such a situation. Suppose Sir, this is the torque, this is the theta. Engine is going to produce some torque which is looking like this. This is the available torque of the engine. Let me write this yellow color say which I have drawn. This is my available torque. Available torque. This is how this torque is going to vary. Sine curve ke form it is varying beta. And if I have connected this against a load which also varies in the same manner, resisting torque, the torque against which my engine is connected, the torque is also varying exactly the same. Sir, this is how my resisting torque is going to vary. They are overlapping each other. I have just drawn them a little bit different so that you can feel the differences beta. It is visible to everybody or not? Let me change the color. Now it is visible. Now this red color and yellow color is clearly visible. Let me zoom this a little bit so that you can feel beta. अरे सुनो मेरी जान, सुनो. Available torque of the engine was, sometimes torque is this. Torque is varying, maximum, again reducing, minimum, again increasing. This is how engine is developing torque. And requirement of the torque was exactly same. It was having same variation. कि sir, resisting torque की requirement is this. तो भैया जिस point पे whatever amount of torque was required, same amount of torque was available with the engine. Do you need any flywheel? No. Do you need any flywheel? No, not at all. क्यों? क्योंकि सर torque theta diagram में available torque is drawn here, resisting torque is drawn here, and दोनों के बीच में between both there is no difference at all. अब कोई difference नहीं है, तो flywheel is not required. This red color से I have drawn resisting torque. Getting a point? No flywheel is required here. No flywheel is required here. Getting a point? बात समझ में आ रही है? So never ever say. On the other hand, एक और सिचुएशन दिखाते हैं आपको, just to clear your mind. Never ever say this thing again. I know many of you are saying because books में it is written that engines में flywheel is required, motor में flywheel नहीं चाहिए होता है. ना बेटा ना. Never say like that. This is the torque. This is theta. Suppose I have a motor. And motor, obviously बात है, motor is going to develop constant torque. Motor is developing this much amount of torque. For 2 by rotation, 1 complete rotation of the crank के लिए I have drawn motor का torque कितना है बेटा? This is the torque of motor, available torque motor का 1 complete cycle के लिए I have drawn. For 1 complete cycle I have drawn this diagram 0 से 2 pi. ठीक है, 1 cycle. अच्छा, but the resisting torque which is required here, it is varying. Sir, if resisting torque was also like this, no flywheel is required. But if my resisting torque का requirement is, sir, sometimes you require 0 torque. अचानक से, all of a sudden, torque की requirement shoots up. It remains constant for some time. And again it decreases to 0 value, and again it remains 0 for rest of the time. बेटे देखो, requirement of energy, मतलब during this 1 cycle how much energy is required? Sir, area under this red वाला curve, how much is the area? अरे sir, यही तो है area. This is the area. This is the energy required. And how much is the energy available with the motor? Sir, area under this ये yellow वाला curve, how much is the energy available? Sir, ये energy, this entire energy, this much amount of energy is being produced. Perfect utilization की बातें कर रहे हैं. Whatever energy is required, same amount of energy is being developed. But जिस point पे जितना energy चाहिए, at any point, how much, whatever energy is required, exactly same amount of energy, same amount of torque is not being developed. Now you can see the differences. Required torque and available torque के बीच में fluctuations are there. तो भैया flywheel will be required. यहां पर देखो दिस इज द मोटर है एंड स्टिल फ्लाईव्हील इज रिक्वायर्ड. दिस इज द केस ऑफ मोटर आई हैव कनेक्टेड. येलो कलर से आई हैव शोन available torque of the motor is developing constant torque, but between the cycle, intra cycle situation mein, you are going to have some fluctuation. Flywheel, you will have to use the flywheel. And what flywheel will do here, sir, whenever flywheel will see any surplus amount of energy, surplus energy ka matlab, sir, available torque is high, requirement is less, so this energy is being wasted na. सर ये वाला एनर्जी, लेट मी, सर दिस एनर्जी इज बीइंग वेस्टेड. फ्लाईव्हील विल एब्जॉर्ब. अवेलेबल ज्यादा है, रिक्वायरमेंट इज वेरी लेस. हियर कम हियर, अवेलेबल टॉर्क इज हाई, रिक्वायरमेंट इज वेरी लेस. फ्लाईव्हील विल एब्जॉर्ब दीज टू एनर्जीज को. फ्लाईव्हील विल एब्जॉर्ब पॉजिटिव फ्लाईव्हील विल एब्जॉर्ब दीज एनर्जीज. एंड व्हेनेवर इट फेसेस अ सिचुएशन कि भैया, whenever it faces a situation the requirement is very high, available torque is very less, that means available energy is only this much, requirement of energy is ye bada amount of energy is required. So bete some part, this much part will be supplied by the motor, but rest who will give? Flywheel will give. Why? How flywheel is going to give you energy? क्योंकि flywheel ने यहां पर absorb किया है, यहां पर absorb किया है, and this amount of energy flywheel will deliver here. Flywheel will deliver this much amount of energy. Getting my point? Yahan par flywheel some energy it is going to deliver. Everybody clear? Negative. Flywheel is going to deliver here. Now, in your mind, make this thing very clear. Never ever say that engines mein flywheel is required, motor mein flywheel is not required. Nah. Forget about motor and engine. Just check whether available torque and resisting torque, available torque and requirement of the torque, both are same or not. If they are not same, flywheel की जरूरत पड़ेगी. If they are exactly same, flywheel is useless for you. Getting a point? I hope everybody is clear till this point. देखो, although flywheel when we will talk in comprehensive detailed courses, so we will go in much detail, obvious सी बात है, but purpose of this entire one short series is to give you all the necessary information of the flywheel in one crisp video. If you are watching this video, if you have already studied flywheel, if you had any doubts, minute doubts, those things will be cleared here. Getting my point? And I will not be surprised that if anybody is saying ki sir, just by looking at these videos only, GATE ke examinations mein some questions were there and I have solved those questions. I will not be surprised. You can very easily, some of the questions can be very easily solved beta. Acha. Questions, how they are going to ask question in the examinations? Somehow if you can find out how much is the delta E max, maximum fluctuation of energy, just find out. Find कर लीजिए how much is this delta E max. Either they will give you in the examination, mean speed they will give, and they will ask कि भाई fluctuation of speed should not be more than plus minus 5%. Tell me what is the moment of inertia of the flywheel का mass बताओ, inertia बताओ. They will ask this kind of question. Or sometimes they will say कि भाई maximum fluctuation of energy is given, flywheel का size, mass and radius of gyration is given, mean speed is given. ये बताओ how much fluctuation of speeds you are going to get. Any of these, there are 4 terms. Some of these will be given, one will be missed, and that you have to calculate. And that thing you have to calculate. Getting my point, beta? Common sense वाली बात. अच्छा. One thing again, very easily students can feel, sir, if this fluctuation of energy is larger, delta E max की वैल्यू जितनी ज्यादा होगी, this will be larger, तो heavy flywheel we are going to use. delta E max ज्यादा होगा तो I का वैल्यू we need higher, यानी heavy flywheel is going to be needed. And that's why sometimes in few situations very heavy flywheels, what can you imagine, this mass of this flywheel is not less than made up of metal. This huge size, this weight, this mass is not less than 300-400 kgs. Very heavy, very heavy. Clear है बेटा? अरे भैया, this is steam engine में लगा हुआ है यार flywheel, so obviously बात है this is going to be heavier. Now to reduce the requirement of flywheel, or we can say to make our flywheel lighter, multi-cylinder engine का concept was introduced in this world. Many people have this thing in mind that कि sir multi-cylinder engine, if I am going to use, power increase होता है, it will increase power, or they say that to increase the power multi-cylinder engine was introduced. Na beta na. Simply if you have to increase the power, for that I have some other jugaad. You know, I am using a piston which looks like this. You know, we have a connecting rod, we have a crank here. Situation is something like this. ऐसा situation है. It is going to give me some power. Obviously बात है. This is engine of my car. If I want to make engine of my truck, more power I need. So I can simply I can use another situation. कि भाई कार में I am going to use this. तो flywheel में, sorry, ट्रक में क्या करेंगे? ट्रक में this piston का साइज इंक्रीज कर देंगे. इमेजिन करो सर, पिस्टन का साइज, दिस इज माय पिस्टन. ट्रक में आई एम गोइंग टू यूज दिस थिंग. वी कैन डू दिस सर. लेसर अमाउंट ऑफ फ्यूल आई हैव यूज्ड हियर, स्मॉल अमाउंट ऑफ फ्यूल, दैट फ्यूल एयर मिक्सचर कंबशन के बाद इट इज गोइंग टू प्रोड्यूस सम अमाउंट ऑफ फोर्स. छोटा सा फोर्स, छोटा सा टॉर्क, वेरी स्मॉल अमाउंट ऑफ टॉर्क आई एम गोइंग टू गेट हियर. ट्रक में bore diameter of piston, cylinder का size, piston का size if I am going to increase. So can you imagine, this thing is capable of producing large amount of power, huge amount of air fuel mixture, huge amount of combustion forces, and that force is going to give me high amount of torque. If my purpose was just to increase power, what is harm here? I can, for car I can use this, for trucks I can use this. For JCB, even heavier requirement, I can use even bigger size of flywheel, bigger size of piston and cylinder, bigger size of engine. That's it. Simple सी बात. What is the need of multiple cylinders? Now, beta, whenever I say multi-cylinder engine concept was not introduced to increase power. Purpose was that we can reduce our dependency on flywheel. If you are talking about single cylinder IC engine, now can you imagine ना, same crankshaft के ऊपर one piston, two piston, 3, 4, 5, 6 pistons. Each piston is going to deliver power on the same crankshaft. If single, suppose let me give you example, and with the help of diagram let me tell you. Beta, careful. For a moment imagine करिए, अरे, for a moment let's imagine if I'm talking about 4-stroke IC engine, 4-stroke IC engine, and 4-stroke IC engine में बटा, careful, how torque is going to vary beta, huge variations are there. Now let me show you, sir. In first stroke, suction stroke, negative torque is there. Engine is not developing any energy. You have to give energy so that it can complete its suction stroke. Compression stroke में even more amount of energy you have to give. Both valves are closed. Now you have to push your piston so that compression stroke can be completed. And once compression is completed, a spark plug will generate a spark inside there. Combustion is going to happen, and huge amount of power you are going to get. And again, once power stroke is complete, piston has come down. Again, exhaust stroke में you have to give some effort on the piston so that piston can move up and combust gases can be thrown out. This is how diagram is going to look. This is how your diagram is going to look. This is torque, this is theta. Getting a point? Suction stroke, compression stroke, this is power stroke, this is exhaust stroke. Now everybody is comfortable. Everybody agrees till this point कि भाई in 4-stroke only single cylinder engine, if you are going to talk, only single cylinder engine is there, only one piston connecting rod crank is there, crankshaft को rotate करने के लिए I have only one piston. So this kind of torque you are going to get. Obviously बात है. Now here if you want to ask me कि sir what is the size of the flywheel which is required, बेटे देखो whatever is the total amount of energy identify कर लीजिए. Total amount of energy, sir ये negative energy, positive energy, huge amount of power is developed, negative energy, total work done, all these areas का summation ले लीजिए, total work done पता चल जाएगा. You will get the total work done and total work done divided by cycle का time period, you will get mean torque. This is the mean torque. Getting my point? This is something which is mean torque. अच्छा, if you will connect the flywheel, what it will do? Sir, flywheel, this is the mean torque and resisting torque भी exactly same होता है ना? Same magnitude का. Now if you will connect the flywheel, surplus amount of energy flywheel will absorb and rest of the places में flywheel is going to supply energy. Now can you feel this big amount of energy your flywheel has to absorb? Larger is the amount of energy flywheel have to deal with, more inertia of the flywheel will be required. So if somebody is going to ask me, yes sir, यहीं लिख देते हैं बेटा, sir if I have single cylinder IC engine, let's come to the new page. If I have a single cylinder IC engine, बहुत ध्यान से, careful. If I have, again, four stroke की बातें कर रहे हैं. 4-stroke IC engine. Single cylinder engine, if I am going to use single cylinder IC engine, if I am going to use, can I say, sir, you are going to have only one cylinder I have. You are going to have suction stroke, compression stroke, power stroke, and then exhaust stroke, and your flywheel will absorb energy. Flywheel get time only here. Flywheel have to absorb energy here only, and rest of the strokes में it has to supply energy. Huge amount of energy it has to absorb, so that rest 3 strokes में it can provide certain amount of energies. Flywheel का size will be higher. Now, if suppose imagine करिए, if I have used 4-cylinder engine, if I have used, instead of having single cylinder, if I have used 4-cylinder engine, same 4-stroke engine की ही बातें कर रहे हैं. This time I have 4 cylinders, similar to this. Here I have 6. मान लीजिए if I have 4 cylinders, sir, C1 cylinder, C2 cylinder, C3 cylinder, C4 cylinder, and all these cylinders are going to give power to the same crankshaft. C1 cylinder में firing order I have set in such a way that C1 cylinder में if I am having suction, compression, power, exhaust, so C2 cylinder में here I will I am having this is power, exhaust, suction, compression. C3 cylinder में I am having this is power, exhaust, suction, compression. C4 cylinder में here I am having power, exhaust, suction, compression. Getting a point? Now, if you look at the crankshaft, just look at the crankshaft. Don't look at the cylinders. Don't look at the cylinders. Look at the crankshaft. Crankshaft के ऊपर, can you feel, sir, in this stroke, energy is available. क्यों? C2 cylinder में power is there. C2 cylinder has given power here, तो crankshaft के पास some positive energy is available here. In the second stroke, यहां पर C3 cylinder से power मिल रही है, some power is available here. C1 cylinder से power मिल रही है सर, here C4 cylinder से power मिल रही है. तो during entire rotation, all strokes में 0 से पाई, पाई से 2 पाई, 2 पाई से 3 पाई, 3 पाई से 4 पाई, all entire cycle में कभी C1 is giving me power, कभी C2 is giving me power, कभी C3 cylinder is giving me power. Getting a point? Now, uniformity of the torque theta diagram you are going to witness. Earlier, diagram was like this. If you are going to use 4 cylinders, sir, one cylinder में negative torque थे. But if you are going to use 4 cylinders, let me draw the diagram. 4 cylinders का if you will draw the diagram, 4 or higher, तो फिर ऐसी सिचुएशन में डायग्राम मालूम है? लेट मी शो यू द डायग्राम. सर, डायग्राम विल बी समथिंग लाइक always positive. Available torque will be fluctuation like this. Getting a point? Fluctuation है, still there is fluctuation, but fluctuation is something like this. Now, if you will take mean torque and resisting torque, sir, mean torque is somewhere here. This is the mean torque. Same resisting torque is there. Now, can you see what are the fluctuations? Now, fluctuations are very, very small. This fluctuation. Flywheel will absorb energy. यहाँ पर flywheel will deliver energy. Imagine करो ना, earlier this amount of energy flywheel has to absorb. अब flywheel को deal करना है only with this much amount of energy. Can you feel? Sir, energy के fluctuations are less, तो flywheel का size भी तो reduce हो जाएगा. Now you understand why multi-cylinder engines are used in the market. क्यों use करते हैं? Getting my point? Why do we use that? Everybody is getting. Market में this is just 4 cylinders का concept I have told. Market में there are 6 cylinders, 8 cylinders. Market में V12 engines are there, V18 engines are there. Although cost is going to be very, very high, क्योंकि all these engines which are made, they are made with the help of expandable mold castings. मतलब for one cylinder they will make a mold, they will do casting, and to take out the cylinder they will break the mold. It's not like कि sir there is a machine, aluminium pour किया, just pour the aluminium and you will get the car का engine. ना, ऐसा नहीं है. For making one engine cylinder, complex engine cylinders के लिए you will have to, from the scratch, 0 से begin करना है. You will have to make the mold, do the casting, and then take out the engine, take out the finishing operations. Mold is broken now. Again, for another car, you have to again start from the scratch. That's why these cars which I'm talking about, V12 engine, V18 engines, cost is going to be very, very high, very, very high cost. Getting a point, beta? Acha, one student asked, sir, I agree that multi-cylinder engine का जो concept है, purpose was not to increase the power. Just to increase the power, you can increase the size of the piston. I agree. Multi-cylinder engine का purpose was something different, to reduce the requirement of my flywheel, to reduce, weight of the flywheel. I agree with that. But can I say, if I'm using only one cylinder, whatever power you are going to get, if I'm using multiple cylinders, so now power, it will increase or not? Yes sir, increase करेगा. Obvious सी बात है. Multiple cylinders, small size के multiple cylinders, they are giving power to the same crankshaft. Obvious सी बात है, power as compared to one, it is multifolds now. Increase हो गई है. But that was never my power. My power was to make torque theta diagram uniform. Uniformity maintain करना was my power, was my aim. Let me write multi-cylinder engine. Aim is to make T theta diagram uniform. फ्लक्चुएशंस को रिड्यूस करना, रिक्वायरमेंट ऑफ फ्लाईव्हील रिड्यूस करना. गेटिंग अ पॉइंट, एंड यू कैन सी दीज सर। अर्लियर देखो ना, सिंगल सिलेंडर इंजन में फ्लक्चुएशंस का लेवल देखिए, समटाइम्स नेगेटिव और नेगेटिव, ये पॉजिटिव और नेगेटिव, दिस इज द फ्लक्चुएशन, लेवल ऑफ फ्लक्चुएशन। यहां देखो सर फ्लक्चुएशन, ये V12 V18 इंजन के बारे में इफ आई टॉक ना, तो यू कांट विद द ओपन आईज यू कांट इवन सी सर ये है फ्लक्चुएशंस V12 V18 इंजन, दिस इज द फ्लक्चुएशन। मतलब if you look from back it seems कि this is a straight line बेटा, almost straight line, getting my point? बात समझ में आ रही है? अच्छा, एग्जामिनेशन में भी they are going to ask some questions, but गेट में they generally don't ask. IES में sometimes they will ask. मल्टी सिलेंडर इंजन में very very careful. How do we solve this बेटा? Again, concept is not going to change. Flywheel का concept whatever we have learned, diagrams, available torque and resisting torque का diagram if you know, तो just fluctuations ही तो calculate करने हैं सर। एग्जाम में they will give you कि भाई resisting torque, they will say that mean torque of certain engine is this is the mean torque. Exactly same you are going to have resisting torque. This is the resisting torque which I have drawn. Just above the mean torque I have drawn. Just above the mean torque I have drawn. Why? I will not tell. I have already discussed this. And the multi-cylinder engine is developing torque in a manner that looks like कुछ इस तरीके से, ये आपको दिखाई पड़ रहा है, समझ रहे हैं? केयरफुल केयरफुल केयरफुल। Something like this it is given. This yellow color से I have drawn multi-cylinder engine का available torque and resisting torque I have drawn. So this is torque, this is theta. These energies will be given. ये energy, ये energy, ये energy, these energies are given in terms of areas they will give. Sir, this is available torque is higher. तो भैया flywheel will absorb this much amount of energy. Flywheel will absorb this energy plus A1. This is area A1. This much amount of energy flywheel will absorb. What about this? Sir, this is negative area. Let me say that this is A2 area. This is again positive area. Let me say that this is A3 area. This is again negative area. Let me say that this is your A4 area. How do we approach these problems? Suppose that this is your point A. This is your point B. This is your point C. Intersection point. This is point D. And this is your point E. Point E is nothing but point A. क्योंकि यहीं से again same cycle is going to start. Getting a point? Either you call it as point E or same cycle will be started again here. Same cycle. The same cycle here which I have drawn, same cycle will be started again here. Same cycle will be started again here. Same cycle will be started again here. Getting a point? This is how things are going to work. Whether you can call it as point E or start end of the cycle is start of new cycle. Simple सी बात, ठीक है? How you have to approach here, कैसे बात करनी है? Let's have a look. बेटा, let's imagine again करना वही है. These areas, fluctuations in terms of energies they have given. What you have to do is suppose, let us suppose, let energy at point A is E. ये E दे रखा है, तो एनर्जी एट पॉइंट A, फ्लाईव्हील माउंट किया ना, फ्लाईव्हील माउंट किया है, तो फ्लाईव्हील इज हैविंग दिस मच अमाउंट ऑफ एनर्जी, एनर्जी एट A, फ्लाईव्हील का एनर्जी एट A, हाउ मच सर? E. एट B पॉइंट कितना हो जाएगा? एनर्जी एट B विल बी हाउ मच सर? फ्रॉम हेयर टू हेयर फ्लाईव्हील हैज एब्जॉर्ब दिस मच अमाउंट ऑफ एनर्जी, A1 एनर्जी एब्जॉर्ब किया है, तो E प्लस A1 हो जाएगा. Energy at C will be how much beta? It will release some amount of energy. So energy at C will be how much? E minus plus A1 already था, माइनस का A2. ठीक है, इधर आ जाओ A3, या यहां पर एनर्जी एट D कितना हो जाएगा? दिस विल बी E प्लस A1 माइनस A2. अगेन it has absorbed some energy A3. Energy at E will be how much beta? Sir, E plus A1 minus A2 plus A3 minus A4. And how many of you can imagine कि sir A1 plus A3 positive areas का summation and negative areas का summation, this is exactly same. और same है this term A1 plus A3 minus A2 minus A4, ये तो जीरो हो जाएगा बेटा. this is going to be zero, जीरो ही होना है, कॉमन सेंस वाली बात. तो this is again E, which is same as energy at A. That's what I have said in the earlier also. At the start, whatever is the energy of the flywheel, at the end of the cycle, you will be having only same amount of energy. Whatever it has absorbed in between, it will deliver within the cycle only. Now, all these energy at A is how much, B pe how much is the energy, C pe how much is the energy, D pe how much is the energy. Just find out all these energies. Just find out all these energies. And if you think, if you see, कि भैया, this seems to be maximum. For example, this is the maximum. And somebody says कि sir, हमको this, ये energy हमको minimum दिखाई पड़ रही है. This is the minimum energy. So whatever is the maximum, whatever is the minimum, differences of these two energies is going to give you delta E max. Delta E max पता है, we have very simple formula. Delta E max is equal to I omega square CS. Put down the values, you will get whatever is desired. Okay, let's solve one question so that you can have even more clarity beta. Question में what they have given. Acha, do one thing. All those people who are watching this session, just pause this video and try to solve this question by yourself. I will give you the answer, but I want no cheating. No cheating. Pause this video and try to solve this question by your own. Turning moment equation of two-stroke engine is given. This 10,000 plus something sin theta plus something cos theta Newton meter. Assuming resisting torque to be constant, power developed by engine at 100 RPM is how much? बताइए बेटा. Pause this video and you have to solve this question. Acha. Now you have solved. Let's check whether you are correct or not. Bete, torque, available torque of the engine, how this engine is developing torque, that is given. This torque T is equal to 10,000 plus 1,000 sin 2 theta minus ka 1200 cos 2 theta. This thing is given. Available torque. Engine is running at 100 RPM. Mean speed is given. अच्छा. RPM में दे रखा है ना, तो mean speed के लिए we can write omega is equal to 2 pi n by 60 होता है. But how much is n? 100. 2 pi n by 60. This is mean speed in radian per second. Power पूछिए ना. How to calculate power? अरे बेटे power होती है, power of the engine is equal to mean torque into mean omega. निकाल लीजिए. Mean omega की value they have given. Mean torque, what is the mean torque? अरे यार, in this equation no need to solve. ना. Whatever term is there which is independent of sin and cos, this term, what do you say? That this is my mean torque. खत्म. This is my mean torque. अरे mean torque दिया है, omega दिया है. Can you directly tell me what is the answer? Just multiply करना है. 10,000 into 2 pi 100 divided by 60. You will get something in watt. Answer पूछा है किलोवाट में, है ना? Don't do these kind of mistakes बेटे. Let me solve this question. 10 किलोवाट में पूछा है ना, डिवाइड बाई 1000 कर दो. 10 into 2 pi into 100 by 60. Value is coming out to be 104 point something. It will be something watt. This is coming out to be 104.719 into 10 raised to power 3 watt. Answers किसमें चाहिए? किलोवाट में. तो क्या लिख सकते हैं? 104.719 kilowatt. Everybody is clear? Everybody is clear? Getting my point? Simple सी बात. Nothing difficult at all. Very easy question. अरे this kind of questions they are going to ask in GATE यार. अच्छा. Once they have asked a really beautiful question बेटा. बहुत खूबसूरत question पूछा है. And let me draw the question. Let me draw the question. Question में they are saying torque and angular speed data over one cycle of a for a shaft carrying a flywheel are shown in the figure. Moment of inertia of the flywheel बताओ how much will it be? And the diagram which they have given is diagram क्या दे रखा है? थोड़ा सा let's make it small a little bit. This is how torque is going to vary with respect to theta. That variation they have given. Let me draw a freehand sketch. They are saying up to certain time, torque developed by the engine is almost zero. All of a sudden, it increases, remains constant for some time, again decreases to some negative value, remains constant for some time, and again reduces to zero. This is how torque is going to vary, beta. This is how torque is going to vary. Acha. Here only they have given data of speed variation. Careful. They have shown how speed is going to vary. Sir, speed का variation they have given. Speed remains constant up to a certain time. It increases linearly to some maximum value, again decreases to the same value. These values are given as, this is speed ka data. This is theta they have given, and here they have given speed, angular velocity omega they have given. Speed is varying between 10 radian per second. This is 10 radian per second, and this peak wala speed, this speed is given as 20 radian per second. Have a look at this question, beta. What is given? This torque, maximum torque is given as 3000 Newton meter, and this negative wala torque, ye value this they have given as minus ka 1500 Newton meter. Okay, this is zero torque, beta. Examiner is asking torque and angular speed data over one cycle of the shaft carrying flywheel is shown in the figure. Moment of inertia of the flywheel बताओ कितना होगा? Very easily can be calculated. देखो, simple सा we have one formula. Very simple सा एक formula है हमारे पास. That delta E max is equal to I omega square CS. Delta E max is equal to I omega square CS. Either you can write this, or somebody, if somebody wants कि sir ये formula नहीं, I will use delta E max is equal to half I omega maximum square minus half I omega minimum square. half I कॉमन ले लीजिए, omega maximum square minus omega minimum. Sir, I want to use this formula. No problem, but use कर लो. This and this, both these formulas are same, yaar. Exactly same. What values they have given? They have given from this data, from this graph only, you have to find out minimum speed during cycle kitni thi. In this cycle, minimum speed was how much? You have just calculated. Maximum speed kitni thi? Sir, 10 radian minimum, 20 radian maximum. Speed का fluctuation इसी के बीच में आपको दिखाई पड़ रहा है. You are witnessing fluctuation of speed between these two values only. Omega maximum का value they have given, omega minimum का value they have given. Omega maximum is how much bate? This omega maximum का value is 20 radian per second. Minimum value is given as 10 radian per second. Moment of inertia, they are asking how much is this I. You have to calculate this value. Somehow, if you can tell me how much is delta E max, very easily we can solve this problem. And how do we calculate delta E max, beta? Delta E max के लिए I have already told that you have to draw two diagrams. कौन कौन से? You have to draw two diagrams. First diagram, which is your available torque. That available torque value is given. And second value you have to draw is resisting torque वाला diagram. And resisting torque वाला diagram कैसा नजर आएगा बेटा? Sir, resisting torque के बारे में they have said nothing. So I will assume that resisting torque generally it is going to be constant and it will be same as mean torque. तो भाई, if I can calculate how much is the mean torque here, it will be same as resisting torque. Mean torque कितना है बेटे? सर mean torque निकाला जाता है work done in one cycle divided by whatever is the time period. And from this graph you have to identify what is work done in one cycle. Sir, this is nothing but area of T theta curve. Area of T theta curve. Area निकाल सकते हैं क्या सर? Area under the curve. What is the area? सर यहाँ तो zero torque है. Here rectangle के form में you have something. How much is the torque? How much is this area? सर ये area निकाल लीजिए. Positive torque multiplied by something. ये value, this value they have given. Let me write. This value they have given here. They have given this value as 0. This is pi by 2. This is pi. And this is 2 pi. Somewhere in between this is 3 pi by 2. ठीक है? This is 0. This is pi. Sorry, pi by 2. This is pi. And this is 2 pi. Sir, time period, I can say from 0 to 2 pi. You have given me the diagram. I am imagining that this is one complete cycle. So time period is given as how much? 0 to 2 pi. This is 2 pi. Divided by 2 pi करिए बेटा. Work done in one cycle, area of the T theta diagram. This area plus this area. यही तो है total work done in one cycle. How much is the total work done in one cycle बेटा? How much is this area? ये area कितना हो जाएगा? 300 into pi by 2 कितना होता है बेटा? This is, sorry, 3000 into pi by 2. Positive area है ना? Positive 3000 था. Here, how much is this area बेटा? This is negative torque. Negative torque. Minus का 1500. Minus का 1500 into how much is this distance बेटा? ये कितना है? Pi. Total work done मिल जाएगा. How much is the work done? This minus this. This comes out to be 0. अरे यार, mean torque तो 0 आ रहा है. And if the mean torque is 0, तो resisting torque, same resisting torque आप कनेक्ट करोगे. सर, resisting torque magnitude wise same as mean torque I am going to take here. बना लीजिए. Let me draw the mean torque. Sir, mean torque will look something like this. Sir, this is the mean torque and this is the same as resisting torque. This is my resisting torque. Now, available torque is drawn, resisting torque is drawn. Now you can see the fluctuations. Fluctuations क्या नजर आ रहे हैं बेटे? Sir, flywheel will absorb energy here, deliver energy here. Either of them you can consider as delta E max. क्यों? Why I am saying this? अरे बेटा, sir, whenever flywheel will absorb energy, this much amount of energy flywheel will absorb. At this point, its energy is going to be maximum. ठीक है? Flywheel will release a certain amount of energy here. Its energy will be minimum here. This minimum energy, it will carry on 0 here. Sir, यहाँ पर flywheel का energy minimum है. Getting a point? Delta E max minus minimum, sorry, maximum energy minus minimum energy, यही तो हो जाएगा. Either you can say this or this. Magnitude wise both are same. Getting a point? Now you know what is the delta E max का value. And if you know delta E max का value, put down the value. How much is delta E max बटे? 3000 into pi by 2. Sir, मिल गया this value. How much is this? 3000 into pi by 2. Everything is given. सब कुछ दिया है. Moment of inertia they were asking. Easily we can calculate बेटा. Very easily we can calculate something kg meter square. Now I am leaving this part. I am not going to solve. All those people who are watching this session, promise me you will give me the answer here. Comment box में I will check After 1-2 days, I will check how many people have watched this and how many people have given me the answer. Just calculate kariye and tell me what is the answer. Something kg per meter, something kg meter square, you are going to get your answer, beta. Getting my point? Getting my point? Acha. That's all. Flywheel mein, they are going to ask these kind of questions. These kind of questions they are going to ask in Flywheel. Next, we have to discuss about another chapter. Another small, but again, very important topic, because very rarely they are going to ask questions from these topics, but whenever questions will be asked, it will be very, very easy question, because very less concepts are there. Na? If your fundamentals are strong here, very easily we can solve it. I will show here. We are going to talk about chapter balancing. What is the meaning of balancing? Balancing of unbalanced forces. You know, in machineries, there are going to be, while this is in running condition, if some unbalanced forces are there, they are going to create huge amount of forced vibrations. And due to forced vibrations, life of machine is going to decrease. You don't believe me? Let me show you that. Larger is the value of this unbalanced force, life will be even lesser. Even more forces, your machine is going to break just in front of you. Let me show you that. Suppose there is a washing machine which is running, and there is some rotating part inside. Earlier it was, running smoothly, but if I put a brick here, that brick is now going to have rotation, and that brick, earlier this machine was balanced, up to a certain limit. If you will touch this machine, you will feel that very small amount of vibrations. There will be some vibrations, but amount of vibration will be very, very less. This machine can run 10 years, up to 10 years. But if you will put a very heavy brick, somebody has thrown brick here, and due to that brick, can you imagine, sir, now in machine, unbalanced forces are increased, and look at the vibration of this machine, and just wait for 2, 3, 4 minutes. After some time, your machine ka situation, put some more masses, some more bricks. Unbalanced forces are going to make your washing machine into trash, scrap, gone, khatam, tata, bye bye, khel khatam. Now you know, unbalanced forces can be very, very harmful. And sir, whenever I switch on my cooler in my home, there are some vibrations, there is some unbalanced force. My cooler is not breaking like this. Abe, in your cooler, in your washing machine, in your all the parts, vibrations are there, but they are very, very limited. There is, somebody has done balancing. Somebody has done balancing. Something left out wala part you can feel ki yes sir, there are some vibrations, and due to these vibrations, your cooler ka life is limited. Sir, after 7 years, there will be some problems. Even in your bikes, in your cars, vibrations are there. So in certain duration, you need servicing. है ना? Automobile का life is 15 years. RTO में when you register your new vehicle, doesn't matter how much maintenance you are going to, put here. Company has given in written, life of the vehicle is 15 years. RTO, your local authority, which gives you permission to drive the vehicle, they imagine कि भाई after 15 years this vehicle will be, due to so many unbalanced forces, it will be damaged internally, very much damaged. After 15 years, they want कि भैया please bring this automobile, bring your car to me so that I can check whether it is fit or not, fit enough to run on the road or not. They will issue again fitness certificate of the vehicle, and they will say कि भैया another 5 years के लिए you can operate this vehicle, but after 5 years again come to me, I will check whether this is fit or not. समझ रहे हैं मेरी बात? So unbalanced forces are going to reduce the life. If the forces, the magnitude is high, so situation can be this worse. It is very important for us to minimize any kind of unbalanced forces. If there is any unbalanced force, so we have to minimize those unbalanced forces. Beta, getting my point? क्लियर है? बात समझ में आ रही है? अच्छा, Now the question is कि why these unbalanced forces are there? Beta, suppose, sir, there is a shaft, है ना? If it is mounted on certain bearings, it is mounted on certain bearings, and some part is there which is mounted here. It may be some disc, gear, flywheel, whatever. Some disc is there which is mounted here. By any chance, by any error, this disc is not perfectly circular. Some manufacturing error, some assembly में some error is there. Due to so many reasons, there may be some source of error. And what is that error? कि भैया this center of mass of this collective device is not passing through the axis of rotation. Axis of rotation क्या होता है मालूम है सर? Axis of rotation, bearings के centers को connect कर दो, and this green color से which I have drawn, this is the axis of rotation. This part have to rotate about this dotted line. If center of mass is just here, I am very, very happy. I will be thankful to the engineers, to the manufacturers कि भैया perfect diagram, perfect design you have given me. But if due to any error, it may be due to manufacturing error, it may be due to design error, it may be due to fitting error, assembly error, whichever reason. But if center of mass is here, a little eccentric, this entire mass is acting here at some small e distance. So can you imagine when this rotor is going to have rotation with omega angular speed? So there will be a centrifugal force, ganda wala centrifugal force in this direction, m_e omega square, and there is no one who can balance this centrifugal force. It will result into the same situation, vibrations, a small amount of vibrations. And if this mass is very heavy, or if this rotating speed is very, very high, so these centrifugal forces are going to be even higher. This is something which I'm saying as unbalanced force, dynamic unbalanced force. Getting my point? I have to balance this. Most of the times, देखो, or when I will say that my system is completely balanced, sir, I will say that my system is completely balanced. For complete balancing, let me write here, for complete balancing, for complete balancing, if you'll ask me, I will say that summation of forces should be 0 and summation of moment should be 0. There should not be any unbalanced force, there should not be any moment, 0 resultant forces, 0 resultant moment. Then only I will say that my system is completely, perfectly, beautifully balanced. Getting open? Both these things have to be 0. Sometimes situations are कि भाई whatever rotating parts के बारे में you are having discussion, this rotating part का axial dimension, length वाला dimension is very, very small. So I can imagine कि this, this real problem can be treated as that mass is rotating in single plane. This kind of situation, if this kind of unbalance is there, to balance this kind of problem, I will just at the back side of this unbalanced mass, I will put some balanced mass, mb mass, at some eb distance. Same plane pe I will mount, so that once it will rotate with omega speed, so it will also create some mb eb omega square, this centrifugal force. And my aim is that this centrifugal force, they are going to cancel each other. If they'll cancel each other, resultant force is 0. All these forces are in the same plane. तो भैया moment का कोई क्वेश्चन ही पैदा नहीं होता है. There is no question of moment at all. Getting your point? So just by making summation of forces 0, I will achieve complete balancing. Moment already is moment. There is no moment generated at all. Getting your point? Only just check for summation of forces 0. That's it. Your work is done. Acha. Sometimes, let me write. If masses are rotating in the same plane, careful, same plane पे rotate कर रहे हैं, तो just check that summation of forces is 0 or not. Summation of forces 0 कर लीजिए. This is something which is called as only do static balancing. Static balancing. Only static balancing is done and my system will be completely balanced. क्योंकि delta summation of moment is 0. There is no moment generated at all. ये by default 0 है. This is by default 0. Only static balancing and I will say my system is balanced. When this kind of situations arise, sir, whenever we are talking about any rotating part whose radial dimensions may be large, but axial along the length of the shaft, it is very, very small. Maybe I'm talking about gear. Let me write, sir. Maybe I'm talking about gear. Maybe I'm talking about flywheel. Maybe I'm talking about disc. Or any other thing whose length wala dimension is very, very small. Radial dimensions can be large. This length is very, very small. Hai? Sometimes you may have situations where parts may have considerable amount of longitudinal dimension. मतलब radial dimension तो है, length along the shaft, its dimension is considerable. Look here, look here, look here. If I'm talking about crankshaft, have you ever seen crankshaft? Any real crankshaft? No. If not, next time whenever you go to any mechanic shop, not bike wala, just go to any car wala workshop, they will and ask him, just bring one samosa and a small treat, 50 rupees, and ask that Chotu. He is not B.Tech, but he knows everything about the engine. Ask him, Bhaiya, please show me. You are, repairing this car. Please, ek bar, please show me how this crankshaft looks. And then he will show you the crankshaft. Crankshaft looks something like this. Sir, this is my crankshaft. Or crankshaft mein, there are so many cranks. One crank is there. This is the crank. With the pin joint, I will connect a connecting rod here. Another crankshaft is here. This is, I will connect, another connecting rod here. Another crankshaft is inside here. Yeah. Another connecting rod, another crank is here. Another, crank is here. Getting a point? These are so many cranks. Line diagram I have shown. Real diagram you can see. Can you imagine? There are so many things. One crank, another crank, another crank, another crank. So many cranks. They are distributed along the length. I can imagine them as masses rotating in different planes. If I draw the diagram, sir, this is your crankshaft. This is your crankshaft. And in this crankshaft which is going to rotate about certain bearing. 3D I am trying to make this diagram. Just bear with me. Sir. One crank is here. One crank. Maybe some eccentricity is there. Crank ko I can show like this. Another crank is somewhere here. Another crank is somewhere here. Another crank is somewhere here. There are so many masses which are rotating in different planes. Different planes mein they are rotating beta. ठीक है ना? In this kind of situations, one shaft is rotating here, another mass is rotating here, another mass is rotating here. There are so many different planes and masses are rotating in separate planes. Clear hai? Imagine kariye beta. Complete diagram I have shown. Real diagram is this. You can show it like this. On the other hand, you may have huge turbine. Can you feel shaft ke upar different planes mein? You can imagine that there are so many masses which are rotating, and if these masses are unbalanced, so bhaiya, if these masses are unbalanced, suppose one bearing I have here, one bearing I have here. Individual planes में you may have some eccentricity, definitely sir. Sir, one mass looks somewhere here. This is mass m1, even distance पे it is rotating. There may be some other mass, maybe somewhere here. This is something m2 mass, e2 distance पे it is going to rotate. Bete, now in this situation, when this shaft is going to have rotation with omega angular speed, so these unbalanced masses, they will produce some centrifugal force, some force here, some force here. This time you have to balance these forces. Summation of these, you have to check कि भैया summation of these forces is zero or not. You have to do static balancing also. You have to do static balancing. Ensure करना है static balancing, as well as you also have to check कि भैया they are going to form some couple or not. One force is here, another force is here. These two forces acting at certain differences, they are going to form some couple. They can also form some couple, na? Yes. So you also have to check whether summation of forces, moment is zero or not. Dynamic balancing. Dynamic balancing, which is written as summation of moment is equal to zero. Forces का summation zero करिए, moments का summation zero करिए, then you can see that now it is completely balanced. Getting my point or not? For complete balancing, you have to do static balancing as well as dynamic balancing in these situations. Earlier वाली situation में when masses were rotating in the same plane, only summation of forces was enough. जरूरत नहीं थी मोमेंट्स के बारे में. नो नीड टू चेक, ऑलरेडी बाय डिफॉल्ट देयर इज नो मोमेंट जनरेटेड. यहां पर मोमेंट्स कैन ऑल्सो बी जनरेटेड. अच्छा, एक और स्पेशल केस देखो. इफ सिस्टम इज स्टैटिकली बैलेंस्ड, इट डजंट मीन डायनेमिकली बैलेंस्ड होगा. और डायनेमिकली बैलेंस्ड है तो स्टैटिकली बैलेंस्ड होगा. इट इज नॉट नेसेसरी. बोथ दीज थिंग्स इंडिविजुअली यू हैव टू चेक. इफ आई से कि भाई ये एम मास, और ध्यान से केयरफुल, दिस इज एम मास, अरे ई डिस्टेंस पे लगा है. दिस इज ऑल्सो एम मास, ई डिस्टेंस पे लगा है. masses are same mass, e distance, same mass, e distance. Now centrifugal force here, centrifugal force here, forces will be same. Summation of force is zero. System looks statically balanced, but still, but a moment force, this force summation is zero, equal and opposite. Still some moment is acting. Or to balance this kind of situations, you have to add two masses at different planes. One mass put here, one balance mass, another balance mass put here, some distance AB, some distance AB. These two masses will produce some force. It will produce some force, and these two forces will develop opposite direction में couple, and this couple is going to balance the previous one. Getting my point? Now the major difference between these two situations, if masses are rotating in the same plane, how do we balance this? Just by adding one mass in the same plane. Only one mass is enough to balance entire thing. But when masses are rotating in different planes, if this system is need to be balanced, you have to add two masses at two different planes, so that system can be completely balanced. Or for complete balancing, you have to check, मेरी जान, you have to check forces का summation zero है या नहीं, moments का summation zero है या नहीं. Getting my point or not? Clear है? Now I will give you a hint, a brief hint, that if masses are rotating in the same plane, how do we balance rotating masses? Balancing of rotating masses के बारे में we are talking. Maybe rotating at the same plane, maybe rotating at different planes. So same planes पे if masses are rotating, how do we balance those? कैसे करते हैं? Let me show you that. Suppose there is a shaft, and in that shaft, same plane, but there are some masses which are rotating, and Side view say if I'll show, it looks like, careful. Side view say if I show, it looks like that there is a mass at some distance r1. Carefully, r1 distance पे, let me use simple free hand sketch बना रहे हैं बेटा. r1 distance पे some mass m1 is there, another r2 distance पे some m2 mass is there, r3 distance पे some m3 mass is there. These masses are rotating in the same plane beta. Same plane पे rotate करना है. Side view I have shown. This system is something like this. It is rotating here. Same plane पे. Side view से I have shown you the configuration. What is the angle between all these masses? You can see in the side view वाला diagram beta. Clear है ना? Same plane पे masses rotate कर रहे हैं. Let me write that this is mass m1 mass है, r1 distance पे है. This is m2 mass which is at r2 distance. Angular position this is given as theta2 distance पे है, theta2 angle पे है. This is m3 mass, r3 distance पे है, and its angular position from reference axis it is given as, इसको मैं this is given as theta 3 है ना. एक काम कर लेते हैं, to avoid any confusion. Or let me make even more general problem. सुनो सर, सिचुएशन दे रखी है कुछ ऐसी. केयरफुल सर, ये लो. All these masses are at certain angles from the reference axis. ये m1 मास लगा हुआ है यहां पर. This is m2 मास लगा हुआ है यहां पर. You are having this is m3 मास लगा हुआ है somewhere here. m1 मास r1 डिस्टेंस पे रेफरेंस प्लेन से θ1 एंगल पे है. सिमिलरली m2 मास r2 डिस्टेंस पे θ2 एंगल पे है बेटा. सिमिलरली m3 मास r3 डिस्टेंस पे θ3 एंगल पे. ऑल दीज एंगल्स आई एम टेकिंग फ्रॉम द रेफरेंस बेटा. दिस इज θ3 एंगल. First of all, you have to check whether this system is completely balanced or not. If this system is completely balanced, I can very easily say summation of all these forces will be 0. If not, if summation of forces is not 0, so फिर I have to, in the same plane, I have to add one balancing mass. Examination में there are two kinds of questions can be asked. First, they will ask कि check करो whether this system is balanced or not. First kind of question, whether this system is balanced or not. Simple सी बात, they are asking system balanced है या नहीं. So you don't have to add any balance mass. Just check this is balanced or not. If yes, it will come out to be 0. If not, something will come out here. You will say not balanced. If this system is not balanced, तो फिर by adding balance masses, now summation of forces will be made as 0. Suppose if this system is not balanced, so by adding, I just have added a balance mass somewhere. This is balance mass MB at some theta B position at some RB distance. I have added. Just by adding this, now all the summation of forces will become 0. Summation of forces will become 0. Only we have to check. Only we have to do static balancing बेटे. So can I write summation of forces 0 कर लीजिए. And summation of forces 0 कैसे करेंगे? Forces are vector quantities. Components कर लीजिए. Components. Summation of forces x component 0 कर लीजिए. Just by adding this balance mass. Can I write, sir, यहां पर centrifugal force will be this, centrifugal force will be this, centrifugal force will be this, centrifugal force will be this. This is m1 r1 omega square, m2 r2 omega square, m3 r3 omega square, mb rb omega square. These are the forces, and all these forces, omega square वाला term is everywhere. तो omega square वाले terms को I'm not representing here just to save my time. वैसे तो force mr omega square होता है, but I will represent this by mr only because omega square anyway it is going to cancel out. I can write m1 r1 cos theta 1 plus m2 r2 cos theta 2 plus m3 r3 cos theta 3 plus all the cos components mb rb cos theta b. All this summation will become 0. जैसे ही I have added balanced mass, जैसे ही I have added balanced mass here, due to presence of this entire thing becomes 0. सिंपल सी बात, सिंपल सी बात. तो यहां से very easily we can write, क्या लिख सकते हैं बेटे, mb rb cos theta b will be equal to how much? This entire thing will become this side minus का कितना हो जाएगा? This will become minus का summation of all these mr cos theta. Getting my point? Can I write this? You have got one equation. Similarly, summation of forces in y direction 0 करेंगे. Similarly, and you will get something like mb rb sin theta b is equal to minus का summation of mr sin theta. Getting a point? Everybody clear or not? अरे भाई, mb rb cos theta b, something you have got, these things you have got, these things you have got, these two equations you have got. Now very easily, very easily, just remove these things. These two equations you have got. With the help of these two equations, can I write from these two equations? Can I write bete? Both side square करके add कर दीजिए. Just square and add. What you will get? Cos square sin square will become 1. So mb rb will become equal to, this square is equal to, यहाँ square under root के अंदर you are going to get minus का whatever, minus summation of mr cos theta square plus summation of mr sin theta. Whatever values you have got, just put square and add. You will get mb rb का value. One thing will be given, other will be asked. They are giving you this value at this distance. How much mass can be added? या फिर this much mass I want to add, at what distance should I add? One thing will be given, other will be asked. Very easily you can calculate that. And if somebody is asking theta, how much is tan theta b? Theta b position बताइए, तो divide कर दीजिए. You can get tan theta b will be how much? Sin upon cos will become minus का summation of whatever is the value mr sin theta divided by minus का summation of mr cos theta. Put these values and you will get what is the value of theta. At what angular position balance mass should be connected? This is the answer. What balance mass should be connected at this distance? This is the answer. Getting a point? This is how you can solve it, beta. And similarly, exactly same manner say you have to solve balancing of masses when masses are rotating in different planes. But here we have only two equations. If masses are rotating in different planes, but nothing is different. It will be just a little bit time taking. Sir, यहाँ पर you have to do summation. Static balancing भी करनी है. Static balancing भी करनी है. That means summation of forces 0 करने हैं. And summation of forces के लिए, sir, summation of forces x component 0 करना है. Summation of forces y component 0 करना है. Put down all these values. Two equations you will get here. Similarly, And the problem doesn't stop here. You will have to do dynamic balancing also, bete. Dynamic balancing. Summation of moment also you have to do. You have to equate to 0. Here also you will calculate moments ka x component, moments ka y component equal to 0. Getting a point? 4 equations. Earlier, sir, it was a little bit, time consuming. Forces, you have calculated forces, x component, y component, cos theta, sin theta, x component, y component, equated it to 0. Sir, here, this process you have to repeat twice. एक बार forces के लिए x, y component, एक बार moments के लिए x and y component. Getting my point or not? Everybody is clear? Everybody is clear? Getting my point? अच्छा, examinations में they will ask, although this problem will become again a very lengthy problem which is beyond the capacity of objective domain. Not this difficult. They will never ask this difficult question. They will ask question in a simpler way, a little simpler way. Before I jump into that, let me discuss sometimes due to reciprocating masses also. This was whatever I have discussed. This was due to rotating masses, how unbalanced forces are there. Sometimes due to reciprocating masses, some unbalanced forces may be there. And how do we calculate that? How to balance that? Let me show you that. Suppose, sir, reciprocating masses, how they can create unbalance? Let me show you that. Let me show you that, sir. Suppose this, what I have shown here, suppose this is a single slider crank mechanism. Engine की बातें कर रहे हैं. This is the crank, this is the connecting rod. This is your piston, very heavy piston, mass m का एक piston है. And this mass m वाला piston, careful. This is a frame. This is pin joint. This is also pin joint, beta. Earlier, at the start, when this crank was horizontal, crank was somewhere here. So piston was somewhere here. यहाँ पर piston था. It has traveled some x distance, and with v velocity, a acceleration, it is moving in this direction. When crank has rotated with theta angle, crank has turned with theta angle, and this crank is rotating with, radius r is given. This is rotating with omega angular velocity. In the time t, when this crank has traveled theta angle, your piston whose mass m is there, it has traveled from here, from outer dead center position, it has traveled some x distance. V velocity say a acceleration say it is moving. So can I say, sir, if it is moving with a acceleration in this direction, so inertia forces will be acting opposite to acceleration. Inertia forces, if I have to show, can I write, sir, inertia forces ma, यही तो होते हैं बेटा. This is inertia forces. Inertia forces. And these inertia forces which piston is going to face, it will get transferred from these links to the frame. And effect will be seen here. The same amount of forces. You are going to have some unbalanced force here in this direction. Acha. When I have told you kinematic analysis of single slider crank mechanism, I have told how much is the acceleration when this crank has rotated by theta amount. Just put down that value here. So can I write this inertia force which will act here on the cylinder? यही तो है unbalanced force. And this unbalanced force can be written as, why this unbalanced force is here? Sir, due to there is a reciprocating mass. Mass is reciprocating, and that inertia force has transferred here. effect of this inertia forces you are going to see here. Unbalanced force can be written as m, and acceleration क्या होता है बेटे? Acceleration is r omega square within bracket cos theta plus cos 2 theta divided by n. Getting a point? If you'll open it a little bit, m r omega square cos theta plus m r omega square cos 2 theta divided by n. This is the total unbalanced force. This unbalanced force का this part, can you imagine? m r omega square something cos theta, m r omega square divided by n cos 2 theta. सर ये डिवाइड बाई n है, and this n का वैल्यू इज लार्ज. एवरीबडी नोज, आई हैव ऑलरेडी टोल्ड. दिस इज r, दिस इज l. n का वैल्यू होता है कनेक्टिंग रॉड का लेंथ डिवाइड बाई r. l बाई r मोर देन 1 होता है दिस वैल्यू, हमेशा, ऑलवेज ऑलवेज. कैन आई से this part of the unbalanced force seems larger? Why? Amplitude is this. This part on the other hand seems to be smaller. m r omega square divided by n. This part is called as major primary unbalanced force, and this part is called as secondary unbalanced force. Getting my point? Getting a point? How do we balance these? Let me give you a glimpse. But generally, cutting all the crap directly, I will discuss results with you. Suno. Generally, we are going to balance only a fraction, not complete balancing. Why? You will get an idea here. Beta suno. Suppose I am talking about primary unbalanced force ka balancing. Sir, how much is the primary unbalanced force here? Sir, primary unbalanced force looks like m r omega square cos theta. This is the primary unbalanced force. One student said, sir, it seems that this is unbalanced force. It seems that this force is acting because there is some mass here, m mass, mounted at r distance. Crank is rotating with omega, so its centrifugal force is going to act here, m r omega square, and it's the component you have drawn here. It is just weird feeling. Although I know that this force has come from here. This is the inertia forces of reciprocating masses. Those have been transferred here. But a student is saying, sir, I am enjoying this feeling. Bhaiya, mass m, some imaginary mass is here, and due to that mass, some centrifugal forces will be there, and that component m r omega square cos theta component is here. Getting a point? Now this mass, rotating mass, can be very easily balanced. How? Sir, just behind that put a balance mass over here. But keep in mind, if you'll do complete balancing, so sir, this real mass which you are going to connect here, real mass का one horizontal component, it will balance here, balance कर लेगा, but one vertical component will arise which is real. अब डोंट से कि सर इसका भी तो एक कंपोनेंट आएगा, डोंट से, दिस इज इमेजिनरी, ये रियलिटी है. एंड इफ यू हैव कनेक्टेड अ रियल मास ओवर हेयर, तो बेटे रियल मास का वन कंपोनेंट हॉरिजॉन्टल आएगा, वन कंपोनेंट वर्टिकल आएगा. हॉरिजॉन्टल अगर कंप्लीट बैलेंस कर लेगा, हेयर कंप्लीट बैलेंसिंग इज डन, तो वर्टिकल में अनबैलेंस्ड फोर्स आ जाएगा ऑफ द सेम मैग्नीट्यूड. दैट्स व्हाई वी नेवर डू कंप्लीट बैलेंसिंग, पार्शियल बैलेंसिंग करते हैं बेटा, पार्शियल बैलेंसिंग. याद होगा आप लोगों को. लेट सी फ्रैक्शन इज बैलेंस्ड. केयरफुल. लेट सी फ्रैक्शन इज बैलेंस्ड. सी फ्रैक्शन से मेरा मतलब है 30%, 40% बैलेंसिंग इज डन. इफ 30% बैलेंसिंग इज डन, 30% बैलेंसिंग का मतलब सर बिहाइंड हेयर जस्ट क्रैंक के अपोजिट साइड में यू हैव कनेक्टेड अ मास mb मास, सम mb मास यू हैव कनेक्टेड rb डिस्टेंस पे on the same crankshaft in such a way that total mr omega square mb rb omega square total balancing is not done. No. Fraction, some fraction is balanced. Sir, this is the unbalanced force. Iska c fraction 30% is balanced. 30% is mb rb omega square. Getting a point? So can I write cmr is equal to mb rb? This is what I mean when I say partial balancing is being done. Even after you have done the partial balancing, so can you imagine, sir, this real mass you have connected, its one component will come out here, its one component will come out here, mb rb omega square, one component here, cos theta wala component, some balancing will be done, not complete, some balancing will be done, so there will be some unbalanced force, remaining unbalanced force. Let me write remaining unbalanced force along line of stroke. How much? कितना हो जाएगा बेटे? This will be how much? mr omega square cos theta ऑलरेडी था, mr omega square cos theta ऑलरेडी था, माइनस का ये फोर्स कितना है बेटे? दिस इज mb rb omega square cos theta and mb rb omega square को व्हाट यू कैन राइट? cmr. कैन आई राइट? माइनस का, let me write mb rb omega square cos theta. If you'll mb rb can be replaced by cmr, can I take common entire this mr omega square cos theta? Within bracket what will be left? Sir, you will be left with 1 minus c. Clear hai beta? This is, even after you have done partial balancing, this is the unbalanced force which is still remained there. Similarly, some new force also is introduced here. Unbalanced force perpendicular to line of stroke. कितना हो जाएगा? How much will it be? कितना हो जाएगा बेटा? This component, sine component. How much? C times mr omega square sine theta. Getting my point? Examination से sometimes they may ask कि भाई 30% balancing we have done, तो बताओ along the line of stroke how much force is remaining? Perpendicular to the line of stroke how much force is going to be there? These kind of questions can be asked beta. Clear है ना? I hope everybody is clear till this point. बातें समझ में आ रही हैं? ठीक है, चलो चलते चलते we will see one last question so that you can get a feeling that what kind of questions can be asked, can be framed in gate examinations from balancing chapter. Question में क्या दिया हुआ है? 3 masses are connected to a rotating shaft supported on bearings A and B. The system is in space where gravitational effect is absent. Gravity नहीं है. Let me draw the diagram. Although, अच्छा diagram they have given. चलो भैया diagram. Let me show you the diagram. Diagram क्या दिया हुआ है? Diagram दिया हुआ. They have already given the diagram. Let me draw the diagram. Sir, one mass is here. M1 mass. M2 mass is here. M3 mass is here. This is M1 mass. ये M2 mass है. ये आपका this is your M3 mass. Distances दे रखे हैं बेटे. This is 0.1 meter. 0.1 meter. 0.2 meter. This is 0.4 meter. These angular positions are given as 120 degree beta. Exam में this is given. and examiner has given this angle as also 120 degree, है ना. Side view orientations they have given, and they have also given front view. Front say this shaft looks something like this. Here we have bearing, here we have bearing, है ना. And all these masses, front say if you'll see, one mass is here, another mass seems to be here. एक ही plane में है, same plane में है बेटा. This is M2 mass, this is M3 mass, or M1 mass is somewhere here. This kind of diagram they have given. ठीक है. Distances, shaft की distances is given as this is 0.1 meter beta. This kind of question they have given. This is also 0.1 meter. ठीक है. Careful, careful, careful. Question को एक बारी again read out carefully. What is given? Three masses are connected to rotating shaft supported on bearings A and B. Let me write. This is bearing A. This is your bearing B. The system is in a space where gravitational effect is absent. मतलब G का value is 0. Gravity is not there. Weightlessness you can feel. Neglect mass of the shaft and rods connecting the masses. Rod, sir, ये जो rod दे रखी है, it is imagine massless है. Rods दे रखी हैं जो these rods which are connecting these masses, massless है. Only masses को consider करो. M1 का value they have given as 10 kg. Let me write. M1 का value they have given as 10 kg. This value is given as 10 kg बेटे. M2 का value they have given as 5 kg. M3 का value they have given as 2.5 kg. For omega 1000 radian per second, when it is rotating with 1000 radian per second, the magnitude of bearing reaction at location B, बताओ how much it is going to be. How do we solve this question बेटे? I will give you a hint, but answer I want from everybody. Answer I want from everybody else. ठीक है ना? I will not solve this question. Question में they have said that these are the bearings बेटे. One bearing is there, one bearing is there. This is bearing A and this is bearing B. समझ गए? Suppose if weight was there, weight consider करना होता तो whatever is total weight W, gravity की वजह से total weight will be there something. This distance 0.1 meter दे रखी है, they have given. This is also 0.1 meter. Sir, it is not rotating. For a moment imagine करिए, this is not rotating due to weight. How much is the reaction you are going to face here? Sir, this bearing will offer W by 2. These are the due to weight, how much reactions are going to be there. Now if I start rotating this system, can you imagine? ये rotate कर रहा है. अच्छा, तुमसे बोल रहा है कि we have taken this system to space. स्पेस में लेकर के गए हैं और स्पेस में वेट इज इक्वल टू m इंटू जी. जी तो 0 होता है. जी इज 0. जी 0 है, इसका मतलब दिस वेट की वजह से रिएक्शंस 0 होंगी बेटे. रिएक्शंस आर गोइंग टू बी 0. सर ये तो 0 हो गया, सर ये तो 0 हो गया. नाउ वेट की वजह से रिएक्शन नहीं है. नाउ व्हाई इट इज गोइंग टू हैव रिएक्शन? अरे भाई, इफ यू विल स्टार्ट रोटेटिंग दिस बाय ओमेगा एंगुलर स्पीड, तो इफ इन दिस प्लेन देयर आर सम मासेस ना, if in this plane some unbalanced force is there, so due to that force reactions will be developed. Yes, definitely reactions will be developed. Let me, sir, क्या करना है? Are they asking to find out balance mass? ना, they are simply asking कि check करके बताओ whether this system is completely balanced or not. If this system is completely balanced, total summation of forces will come out to be 0. So bearing में reactions are going to be 0. But if this system is not balanced, what you have to do? You have to identify ये centrifugal force, ये सेंट्रीफ्यूगल फोर्स, ऑल दीज सेंट्रीफ्यूगल फोर्सेस का रिजल्टेंट कितना है, रिजल्टेंट कितना है. इफ यू कैन कैलकुलेट रिजल्टेंट, हाउ डू वी कैलकुलेट रिजल्टेंट? समेशन ऑफ फोर्सेस जीरो नहीं करने हैं, कीप इन माइंड जीरो नहीं करने हैं. व्हाट यू हैव टू डू, फाइंड आउट एक्स कंपोनेंट कितना है, वाई कंपोनेंट कितना है, फाइंड आउट करो. फोर्सेस इन एक्स कंपोनेंट, हाउ मेनी फोर्सेस आर देयर, निकालने हैं. फोर्सेस, समेशन ऑफ फोर्सेस एक्स कंपोनेंट निकालो, समेशन ऑफ फोर्सेस वाई कंपोनेंट कैलकुलेट करो, डोंट मेक इट जीरो. वंस यू हैव दीज फोर्सेस, वंस यू हैव दीज फोर्सेस, तो रिजल्टेंट अनबैलेंस्ड फोर्स निकल जाएगा आपका. गेटिंग पॉइंट? हाउ मच इज अनबैलेंस्ड फोर्स, सेंट्रीफ्यूगल फोर्स, दैट विल बी अंडर रूट summation of forces in x direction, whatever is you have calculated, square plus summation of forces in y direction, whatever you have calculated, square. Put these values, you will get unbalanced forces, and whatever unbalanced force is there, वो कहाँ act हो रहा है बेटा? This force is going to act, sir, ये this is your shaft, this is your shaft. Whatever unbalanced force is there, है ना, suppose some force is acting here, this is the force. Due to this force, now reactions F by 2, F by 2. Getting my point? These are going to be reactions. This is being asked. Everybody is getting my point. What do you have to do? अरे भाई, mass, radius, angular position, everything is given. Calculate कर लो. How much is x component में force? How much is y component में force? सारे बच्चे, can you give me the answer? देखो, easy क्वेश्चन है. Entire concept I have told. Entire concept I have told. चलो ठीक है, छोड़ो यार. Let me give the answer. तुम just pause this video and try to solve this. हो गया? Now let me give you the answer. Answer दे देते हैं. Summation of forces x direction में how much will it be? कितना हो जाएगा बेटा? x direction में how many forces are there? लिख लो बेटा. सुनो सुनो सुनो. They have given you this angle is 120 डिग्री. ये एंगल 120 डिग्री दिया हुआ है. अच्छा सर, आपने बोला था θ1. सर ये तो हॉरिजॉन्टल में ही है. यहां से, दिस इज माय रेफरेंस प्लेन, यहां से आई विल कैलकुलेट ऑल द एंगल्स. दिस इज माय रेफरेंस प्लेन. ये लो, दिस इज माय रेफरेंस प्लेन. ऑल द एंगल्स आई विल कैलकुलेट फ्रॉम हियर. सो फ्रॉम हियर θ1 इज हाउ मच बेटा? 0. θ2 कितना नजर आ रहा है सर? θ2 इज 120 डिग्री. θ2 की वैल्यू कितनी नजर आ रही है? दिस θ2 comes out to be 120 डिग्री. θ3 in the same sense I have to take, sir, θ3 ये लेना है हमको. दिस इज θ3. θ3 कितना हो जाएगा? दिस θ3, this comes out to be 240. They have given you this 120. I will not consider this. I will consider all these angles in same anti-clockwise, anti-clockwise, anti-clockwise sense. Now put down these values. X direction में what will be the forces बेटा? m1 r1 ओमेगा स्क्वायर. ओमेगा स्क्वायर कॉमन ले लेते हैं. m1 r1, हाउ मच इज m1? 10. r1 कितना है? 0.1 cos 0 प्लस दिस cos कंपोनेंट कितना हो जाएगा? m2 r2. m2 कितना है बेटे? 5. r2 0.2. हाउ मच इज cos 120 प्लस m3. हाउ मच इज m3? 2.5. r3 is how much? 0.4 cos 240. Find out how much is this value बेटा. ये वैल्यू कितनी आ रही है? Let me check with the calculator. 10 into 0.1 cos 0, this is 1. 1 plus 5 into 2 कितना होता है? 1 cos 120. Cos 120 plus 2.4. This is also 1 cos 240 plus cos 240. This value comes out to be 0. X component of forces is 0. अरे वाह, surprised. I am surprised. X component are coming out to be 0. Y component के लिए बेटे similarly we will put for y component. Y component कितना हो जाएगा? ओमेगा स्क्वायर कॉमन ले लीजिए. इनसाइड में यू आर गोइंग टू हैव m1 r1 sin 0. sin 0 वाला कंपोनेंट तो 0 है बेटा. प्लस m2 r2 sin 120. m2 r2 कितना हो जाएगा? 5 into 0.2 sin 120 प्लस 2.5 into 0.4 sin 240 put down all these values. चेक करिए बेटा, ये कितना हो जाएगा 5 into 2.1 sin 120 plus something sin 240. This value again comes out to be 0. क्या बात है, this again comes out to be 0. Sir, this value summation of forces y direction में this is also 0. x component में 0 force, y 0 force. That means total unbalanced force is a 0. System is balanced bete. System is balanced. There is no unbalanced force. There is no unbalanced force. And when there is no unbalanced force, so can I say how much is going to be reaction? Zero reaction. Zero reaction is going to be there. Getting a point? So this is how questions can be asked in the examinations. Clear, bete? That's all. That's all. In this very short, crisp video, I have covered two major important topics for you. Flywheel and balancing is covered. I hope you people have enjoyed, you people have learned something. है ना? Next video में whenever we will meet, we will discuss another new topic. Vibrations के बारे में we are going to discuss. So see you guys in the next session. Till that time, thank you बच्चों. Goodbye. Love you all मेरी जान.